Hi children, good morning. Today I'm going to discuss the chapter Arithmetic Progression of Class 10 CBSE. So, what is an AP? What will be the common difference of an AP? What is the nth term of an AP? And what is the sum of first n terms of an AP? All these things we can discuss and then discuss the exercise questions also. Okay, children, so let us start with AP, arithmetic progression. What is arithmetic progression? So, with an example, I will explain here. Listen, I take a number 2. I take a number 2. Now, I am going to add 3 to this number. Then I will get 5. Then again, I am going to add 3 with this number. I will get 8. Again, I am going to add 3 with this number. Then I will get 11, etc. See, we will get a sequence by adding a fixed number to the preceding term. We will get a sequence. Such a sequence is called arithmetic progression. See, by adding 3 to the number 2, I added here 3. So I got 5. Again, I added 3. I got 7, 8. Again 3, 11, etc. So by adding the fixed number, the same number we are adding to each term, we are getting a sequence. This sequence is called arithmetic progression, and that fixed number is called common difference. That fixed number is called common difference. That fixed number is called common difference, and the letter we are using for that is D. So common difference. How we get that fixed number? That fixed number we will get by subtracting second term minus first term. See, 5 minus 2, or third term minus second term. So a3 minus a2. So we can represent the terms like this. For example, see, suppose first term is a1, second term is a2, third term is a3. When we represent like this, we can say the common difference we will get like this: a2 minus a1, a3 minus a2. Example, 5 minus 2 is 3, 8 minus 5 is 3, 11 minus 8 is 3. So all these are 3. We are getting 3. The common difference will be the same. That means that is a fixed number. Okay. So the common difference is equal to what? Common difference is equal to, we can write a2 minus a1, or we can write a3 minus a2. a3 minus a2. Generally, we can write like this: an minus an minus 1. You can check here. Suppose you give instead of n 3, what happened? a3 minus, what is 3 minus 1? a3 minus 1, a3 minus 1. 3 minus 1 will be 2. See, a3 minus a2. So suppose you are giving 2 here instead of n. Then what happened? a2 minus 1. What is 2 minus 1? 1. So a2 minus a1. So this is the general formula. This is the general formula to find the common difference, or simply we can do a2 minus a1. So that is the common difference. Now let us discuss what it will be the nth term. See here, suppose a1 comma a2 comma a3 etc. an is a general term. So what will be the general term, or nth term? What will be the general term? What is the equation for general term that we can find here? See, the general term, first term, suppose a is the first term. How we get the second term? With a, we have to add the common difference, we will get the second term. Now with this a, when we add with this a2 second term, when we add again the common difference, we will get the third term, that is equal to a plus d is what? It is 2d, a plus 2d. So this is the third term. Now what will be the fourth term? With this a plus 2d, you have to add again d. Then what you get? Equal to a plus 3d. Okay, so this is the fourth term, etc. So we can write the first term is a, and the second term a2 is equal to what? It is a plus d. The common difference we have to add. Then what is a3? a3 is equal to what? A plus 2d. Then what is a4? a4 also we have written there. What is a4? a plus 3d. Then what will be a5? a5, with this we can say it will be a plus 4d. So a plus 4d will be a5. Then what will be a 100th term? What will be the 100th term? It will be a plus 99d. It will be a plus 99d. So same way we can write what will be the nth term, general term, nth term. It will be what? A plus, see here 100, here 99. So here n, here we will have what? N minus 1 into d. It will be n minus 1 into d. So we got an is equal to a plus n minus 1 into d. So we can write the nth term. This is the general term or the nth term of an AP, that is equal to a plus n minus 1 into d. A plus n minus 1 into d. This is the equation to find the general term or the nth term of an AP. Okay. Now from this general term, this nth term, we can find the number of terms. The number of terms n is equal to n, we can find this from this equation, that is n is equal to an minus an minus a divided by d divided by d divided by d plus 1. See, an minus a divided by d plus 1. Once again I write here an minus a all divided by d plus 1. So this is the equation to find the nth term, to find the number of terms. This equation we can use. N is equal to an minus a divided by d plus 1. So this is the equation to find the nth term of this AP, nth term of this AP, and the number of terms of the AP. Okay children, so let us move to the next topic, that is Sn. Sn is equal to n by 2 into 2a plus n minus 1 into d. Sn is equal to what? N by 2 into 2a plus n minus 1 into d. This is the equation to find the sum of first n terms. For example, I will tell you here, see here, a1 comma a2 comma a3 comma a4 etc. are the terms. Then s1 means first term, sum of first term, that will be a1. s2 will be what? s2 is equal to a1 plus a2. Then what will be s3 is equal to a1 plus a2 plus a3. So same way we can find Sn. The general equation to find Sn is equal to what? N by 2 into 2a plus n minus 1 into d. Now suppose we have the first term and the last term we can use this equation. Sn is equal to n by 2 into first term plus last term. So first term plus last term. First term plus last term, or you can write that is equal to n by 2 into, generally you can write like this, n by 2 into first term is a plus last term we can take l or an or l we can take as the last term. So n by 2 into a plus an. So there are two equations to find sum of n terms, that is first one is this one, and second one is this one, that is Sn is equal to n by 2 into a plus an. So these two equations, out of these two equations, according to the situation, you can select which equation you need. Now let us discuss how to find general term, nth term from the sum of n terms are given. Okay, so Sn is given. How to find the nth term? So it is very easy. Sn is equal to n is equal to Sn minus Sn minus 1. So when you apply here, if you have Sn and Sn minus 1, when you apply in this equation, directly you will get the nth term of this AP. So nth term of an AP, to find nth term of an AP from the sum of n terms is Sn minus Sn minus 1. So this equation also you can use according to the question. Okay children, so now let us discuss exercise questions of this chapter. So exercise 5.1. Let us discuss exercise 5.1. Question number 1. In which of the following situations does the list of numbers involved make an arithmetic progression, and why? Look here, first question. The taxi fare after each kilometer, when the fare is rupees 15 for the first kilometer and rupees 8 for each additional kilometer. The taxi fare after each kilometer, when the fare is rupees 15 for the first kilometer and rupees 8 for each additional kilometer. So it can be observed that taxi fare for the first kilometer. What is the taxi fare for the first kilometer? The taxi fare for the first kilometer, it is rupees 15. So the taxi fare for the first kilometer, it is rupees 15. Now the taxi fare for the second kilometer. Taxi fare for the second kilometer, you can see 15 plus 8. With this 15 you have to add another kilometer, it is rupees 88 rupees. So 15 plus 8 is 23. Now the taxi fare for the first 3 kilometer, it will be this 23 plus 8, that is equal to 31. And taxi fare for the first 4 kilometer, the first 4 kilometer, you can see it is 31 plus 8 equal to 39. So clearly we can say, clearly 15 comma 23 comma 31 comma 39 forms an AP. Why? Because every term is 8 more than the preceding term. That is, the common difference of this AP is 8. 8 is adding to the preceding term, so it is an AP. Now let us move to the second question. What is the second question? The amount of air present in a cylinder when a vacuum pump removes 1 by 4 of the air remaining in the cylinder at a time. The amount of air present in a cylinder when a vacuum pump removes 1 by 4 of the air remaining in the cylinder at a time. So let the initial volume of air in the cylinder we can take as V. So V liter volume will be there. The initial volume of air we can take as V liter. In each stroke, the vacuum pump removes 1 by 4 of the air remaining. 1 by 4 of the air remaining in the cylinder at a time. So it is for each stroke, the vacuum pump removes what? Removes 1 by 4 of the air remaining in the cylinder at a time. So in other words, we can say what? What we can say? 1 minus 1 by 4, that is 3 by 4 of the 3 by 4th of the part of what of air will remain. Therefore volumes will be, so the volumes we can write as like this. The first volume is V. The first volume is, we can consider as V, the first volume as V, and second 1 by 4 reduced, 1 by 4 reduced, so removes the 1 by 4, that means it will be 3 by 4 of V. Then again 1 by 4 removes, that means again 3 by 4 of that volume, so 3 by 4 into 3 by 4, 3 by 4 into 3 by 4 will be 3 by 4 the whole square V. Next again 3 by 4 reduced, that means 1 by 4 reduced, that means 3 by 4th of the volume, so 3 by 4 into 3 by 4 again, then we will get 3 by 4 cube V. So this we know this is a square cube like this, it will not be a arithmetic progression. It will not be like added, it's just like multiplication. Okay, so it is not added. So clearly it can be observed that the adjacent terms of this series do not, the adjacent terms of this sequence do not have the same difference, there will be not same difference, so therefore this will not form an AP. Now look, question number 3. The cost of digging a well after every meter of digging, when it costs rupees 150 for the first meter and rises by rupees 50 for each subsequent meter. So for the first meter it is rupees 150, and for the subsequent meters it is rupees 50 each. So the answer, cost of digging first meter, for cost of digging the first meter, what will be the cost, what will be the amount will be what, 150. Now cost of digging first 2 meters, it will be 150 plus 50, 150 plus 50 equal to what, equal to 200. Now cost of digging for first 3 meters, it will be 200 plus 50, that is 250, and so on. So clearly you can say what, 150 comma 200, 250, 300, 350, etc. forms an AP, because every term is 50 more than the preceding term, that is the common difference of this AP is 50. Now let us discuss the last sub question of first question. See here, the amount of money in the account every year when rupees 10,000 is deposited at compound interest at rupees at 8 percentage per annum, at 8 percentage per annum. The amount of money in the account every year when 10,000 is deposited at compound interest, at 8 percentage per annum. So we know that the equation for compound interest, the amount for the compound interest we have studied in class 8. So the equation is P into 1 plus R divided by 100 the all raised to n. Okay, this is the equation to find the amount as per the compound interest. Okay children, so we know that if rupees P is deposited, the principal amount P is deposited at R percentage, the compound interest per annum for n years, the compound interest will be, that means our money will be what, P into 1 plus R divided by 100 the all raised to n after n years. After n years we will have this much money. Okay, so therefore after every year, so for each year we can calculate like this. For the first year it will be 10,000 into 1 plus 8 divided by 100, and for the second year it will be 1 plus 8 1 plus 10,000 into 1 plus 8 divided by 100 the all square. Next year, the third year, it will be 10,000 into 1 plus 8 divided by 100 the whole cube. So anyway, here square, cube, like that we have. Okay, we are multiplying with the square and cube with the same number, that means 1 plus 8 by 100. We are multiplying with 1 plus 8 by 100, so not adding. So here clearly we can say this is not an AP, because the adjacent terms of this sequence, do not have the same difference. We will not have the same difference because we are multiplying by the same number, not addition. Okay, so they have the difference, the common difference is do not have a common difference. It is not common. So that's why this is not an AP. So the adjacent terms of this sequence do not have the same common difference. Same difference is not there. So we can say this is not an AP. Okay, children. So next we can move to exercise 5.1 question number 2. That will be in the part 2. Okay, this will be in the part 1, and next remaining questions will be there in part 2. Thank you, children.